So on this last one, before we go on break, we're looking at something called a hyperbola, which is closely related to an ellipse. The only difference is that the focal points are now on the outside, meaning this value right here, these are focal points. Usually those are in between those vertices. Now they're on the outside, so that means the eccentricity is now bigger than 1. All right? And the way we actually construct this, I'll go into the details of this a little bit later, but because we have a shorter period, I just want to get to the how-tos today. Right? So a lot of things are the same. You can see that we have a major axis, right? Just right here. Just like before, these can open up vertically or horizontally. Right? So this value from here to here, or from here to here, depending which direction this hyperbola is opening. Right? Now, it kind of looks like a curve of like a parabola, so there's some differences, definitely. And we'll, again, talk about those major things at a later time. We also have the minor axis, which is going the other direction, which we'll talk about, right? The B value, here, here. You'll notice B can be bigger than A can be bigger than B, just depending on the different parameters of the equation. And then we have the C value, which is going way out here, all the way to the center. Now this length right here happens to be the same length as this. There's a similar relationship with the ellipse. So now this is C value, but in the ellipse, this was the A value. So we had A squared equals B squared plus C squared. All right? But on this one, well, now C is back to being the hypotenuse. So one major difference about the hyperbolas compared to the ellipse is that we're back to Pythagorean theorem. So this is one of those small but major details that makes a difference on how well you do on the ellipse. So like if you accidentally use this formula on the ellipse, it'll come out wrong. If you use the ellipse formula on the hyperbola, it'll come out wrong. So remember, the difference between the ellipse and the hyperbola is that these two are switched. Right? So C is back to being that longer hypotenuse length. And we have something different. We have some asymptotes that help us guide and help us draw everything. So the first thing we're going to do is basically make this frame right here. I call it a frame, this little box. Get all those values with A and B, and then dot this thing all the way around. Then we're going to get these hypotenuses, like make an X that goes right through the center. And that's going to help us draw the hyperbolas, because with the asymptotes we know the graph will not go through them. That's why we need them. It kind of guides us to where we should be going. Okay? It's still a rough sketch, but it wants to be as accurate as possible. Okay? So, just like before, we have two different forms. We have this form, and it's slightly different, just slightly, not that big of a difference. Oops, highlight. Right. So you'll notice that A is first, no matter what. So on both of these, A is first. If A is the first, if X is first here, you know it's going to open up left, right, horizontal. I'll switch to darker blue. And if we have the Y is first, it's going to open up vertically. Okay. And you also notice that there's a subtraction sign here instead of addition sign. So that's the main way you can tell, looking at the equation, is this an ellipse or a hyperbola? One of them will be negative if it is a hyperbola. Okay? One of them will be negative. Got that? Still equal to 1. That has not changed. All right. But other than that, I think it's pretty much, to the point. We're going to do the same 4 things, or 3 things that we did before. Find the center, vertice, foci, and now we have the slopes. Now that's just for the slopes. There is a way to actually find the equations, like the y equals mx plus b. But we're just going to basically find the rise over run of them, which is really simple. It's either a over b or b over a, depending if it's opening left, right, or up, down. Okay? So let's get started. So let's go here. Let's do A together. This. So start by finding the center. I'll tell you what the center is not. It's not 3, -1. It is going to be x, y, right? So the h is actually right here, and the k is over here. So before with the ellipse, we usually had x here, and y here is always xy, left, right. So it could be written either way. So we have to be careful not to just go in order, but to look at the variables. So our center is at -1, -3. Gotcha? Yeah. And we can graph this as we go. So we can go down here, go -1, -3. Center. Okay. Then, so that's, I'm just going to check these off as I go so I know by the end of the problem I've actually finished the problem. Sometimes that's the biggest problem. Next will be vertices. So, vertices. Okay. And that's going to be done just using, remember it's on the major axis, which is always A, so that's going to involve this right here. So if A squared is 9, you know A is 3. And I just need to go, since we're opening up and down, because Y is first, I just need to go up and down 3 from my center point, right? So, no, stay here. So we're going to have -1, -3, our center, and then on the Y, since it's a, vertical problem, it's a Y, I'm going to go up and down 3. Now, if this was an x problem, I would put this plus or minus on the x coordinate. I'd be moving left to right. So this isn't a template on every single problem. You're always going to do it this way. You have to adjust depending on if it's an opening left, right, or up, down. Open up, down, all the work is going to be on the y-axis naturally, right? So in general, for these, it's going to be your center point, which is h, k, plus or minus whatever a equals. Okay? When it's opening up and down. And let's plot those, right? So we have, what, -1, 6, and -1, 0. Go down here and do that. -1, 6, up 3. -1, 0, down 3. These are the vertices, just the vertices. And check. Alright, next we could do the, let's say, the foci. Focal points, foci. And that involves the c value. So we're going to use this one right here. Square root of a squared plus b squared, Pythagorean theorem. So we're going to use, we need b, so let's get b. 16 is b squared, so b is 4. So c is going to be the square root of those squares, 9 and 16. In this case, it comes out to square root of 25, which is just 5. Nice numbers to start off with. So it's very similar to the vertices. I'm going to start off with my center point, right? So both the vertices and the foci both start from the center. So they both need this, whatever this is up here, you're using that. And this time we're going up and down, instead of 3 from A, we're using C. So we're going up and down 5. So we're just going to go 2 more, from 3 we're going to go to 5 on each one of these. Right, and in general, well, we could write it out in general too, why not? We could say that it's h, k plus or minus c to get the foci. So I'm going to go up 5 from the center, which is also just 2 more from our vertice points. Good. And then why not? Let's do our B as well. We got our B is 4, so we can do our minor axis, which is going to be 4 each way. Yeah, 1, 2, 3, 4. Left or right, and then 1, 2, 3, 4 there. And I'll do a little dotted line going all the way around the frame. Now, it's not part of the actual graph, so you don't really have to put this, but I suggested in the beginning just to help out with the asymptotes. How are we doing? Okay, good. So our slopes or asymptotes of our slopes of asymptotes. What are we doing? Blue. Yeah. Just look at the rise over the run from the center. That's the easiest way to do it. So we're going to go up 3, and then right or left 4. All right, so up 3, over 4, and I can go up 3 that way or that way. That means we have a plus or minus situation because we have 2 asymptotes. One's a positive slope, one's a negative slope. Okay. And in general, you can see, well, what's 3 if you go up here? Well, 3 is A, right? And 4 is B. So there's a general way to get this, and that's just A over B. And mind you, it's the opposite if it's opening the other direction. Okay, so if this is opening left and right, it would be B over A, and I think up here, if I remember correctly, if you look right here at the very top, it says y equals negative B over A instead of A over B. That's because it's opening left and right. So it's not worth memorizing this stuff. It's easier just to look at your graph and just count the rise and run and say that's what it is, as opposed to doing it more formulaic. Okay. But there is a pattern if you're looking for it. Okay. If you want, okay, let's draw that. Let's draw those equations. So we have, or those lines. Now it's just going through the corners. Just go take the corners here. This is why we want the frame, and then go through the center. A nice straight line should work. If you draw a straight line and it doesn't go through all 3 points, that means there's some counting of squares that's gone wrong, which I did this morning, so it can happen. Let's see here. Is there a line tool here? I don't know. And it's nice to have a actual straight edge. It doesn't have to be a ruler. Sometimes the side of a calculator is straight enough to get a straight line, or an ID card is usually a good go-to if you have that. Debit card, MasterCard. There we go. Alright, and we're ready to graph. We're going to graph wherever the focal points are so we don't accidentally do the wrong side. So we got the focal points here. So I like to start by really close to the asymptote and then work my way closer to the vertice. All right. So I start really, really close here, and then I kind of go further away. Just remember, you never actually cross the asymptote. It approaches it. All right. This is a line where usually we have this like in the trigonometry. These are vertical lines because they're undefined. Well, our undefineds are on these diagonals now. That's what's going on. So it helps us guide our graphing. We can never divide by 0, so meaning we can never cross the asymptote. There we go. That's not as good. All right, excellent. Very good. And we have checked all the requirements here. We did foci. We did the slopes of the asymptotes down here. Okay. So hopefully this looks very familiar. If you did your homework last night, this looks very familiar. Yeah, the graph comes out different, but what we're doing as far as getting vertices and foci and the center, and then here on B, completing the square, it's, I'd say 80% review. Okay, so let's try doing B. Let's try doing B. Do you guys want to try this, or do you want me to go over it? You guys can try it. Okay, I'm working through the complete square part right now. I mentioned if you did all your ellipses last night or the night before, this looks very, very familiar. Nothing has changed. If you have not done it, you might be like, wait a minute, how come this and how'd you get that? That's why you need to keep up on your assignments, because they all build on each other. So you should end up with that. Okay? So we'll take the center, -1, and do plus or minus 2, left to right, and then comma K. Okay? So let's do that. So we have 1, 2, 1, 2. Good. And our foci, very similar. We'll have -1 plus or minus C, comma 4. Okay? And the C, I think, is the same, so it's going to be square root of the 4 and the 9. So we get root 13, which is about, was it 3.6? Okay. So if this is 2, 3.6. And then our minor, which is 3, is now vertical. 1, 2, 3. There we go. Much better. Okay. And our asymptotes, our slopes. Okay. Slopes will be up 3 over 2, plus or minus. Rise is 3, run is 2 in both directions. There we go. Yeah, the most important question, I guess, kind of skipped, which is, from the very beginning, which way is it opening? We did that for the ellipse, but since the x is positive and the y is negative, we know it should be opening left and right. Whereas the first one, the y was positive, the x was negative, that's opening up and down. So whatever variable is listed first here, or whichever one's the positive one, that's the direction we're going to be opening. Right, so now we can get our graph on there, going through our vertices that are on the left and right hand side. There we go. Perfect. And double check directions, make sure we did everything, including sketch the graph, and I think we're good to go. Oh, finish this was root 13. Alright, let's get over to the next page, and these are going to be the shorter problems where you just have to do maybe a little sketching, but our goal is to get the equation in standard form. So if I give you a foci or length, something graphical, you can work backwards. And just remember, when you're trying to find the equation of a ellipse or a hyperbola in this case, you need to find the center, which is HK, and you need to find A and B. Right? Those are the only things you need. So all that information you're given is just to find the center and A and B. And A is this length from the center, right, going towards your graph. B is the minor that goes from the center the opposite direction. Okay? So graphically, we can figure this out one way or another. All right, good. So sketch this to start off with. We got vertices. Vertices at -1, -1, and 1, -9. So this is like third quadrant. 1, -1, let's say it's right there. 1, -9, which is right there. And vertices are automatically on the major axis. Okay? So this is going to help us find out what A equals. Vertices are always on that major axis. So it's all this relationship stuff we have to understand. Right? Now A is the length from the center to the vertices. So we don't know what the center is. So we've got to figure that out. So what is the middle or the center of the vertices? What is this coordinate? All right? So since we're looking for something in the middle, we could just do midpoint of these two. All right? That'll give us the middle. If you can figure it out without using the midpoint formula, that's fine as well. But this always works. You're trying to find the middle, 2 points, do the midpoint formula. 1 plus 1 is 2. 2 divided by 2 is 1. So no surprise, the middle is going to stay on the ones. And then -1 minus 9 is -10. Half of that is -5. So we now know that this is at 1, -5. And we know that this length right here, right, that's A. So how far is it from here to here? Remember, this is 1, -1. So how far apart are these two? If you needed to, you could use distance formula, but my hope is that you can figure out how far -1 is from -5 without it. Yeah, just 4. So now we know A is equal to 4. And as I said before, you need 3 things. Right? You need the center, A, and B. So we have the center, 1, -5. We have A, and then we need B. And that's what the second one. This is going to help us find B. Minor axis is always going to be B equals. All right? So that length, they said, is 6. So that means all the way across. This whole length of the whole thing all the way across is 6. But B is only from the center to the point. So how long is B? And that's where we get that B value. Well, if the whole thing is 6 long, half of it must be the distance from the center to each side. Plus the center plus or minus 3. So as long as we know what we're looking for, we're going to know when we're finished, right? If we know to look for the center A and B, as soon as you find those things, you say, okay, I have everything I need to write the equation, and we can do it. Now, which direction is this opening? We need to know that, because it could be this one, and it could be this one, right? So if we need to know if we put X first or Y first. So which one is it? How can you tell? All right. So we have vertices. That will let you know which way it's opening. Vertices only open the direction, right, that they're placed. So since the vertices are vertical, we know that if we actually graph this whole thing, it'd be looking like this, which means Y is going to come first. We got Y squared minus X squared equals 1. Got it. And our center is 5, negative 1. Or sorry, 1, negative 5. So I'm going to have, be careful on this part, plus 5 here for the Y, and minus 1 over here for the X. Okay. A always goes below the first part here. So we got my A squared, which is 4. So that makes this 16. And then over here I got my B squared, which is going to be 9. Okay. So these things are all about relationships. And let's just finish up this last one together because of time's sake. E is the eccentricity, which is going to be bigger than 1 now because it's a hyperbola, so that means this number on the bottom is going to be smaller than the number on top. Just recall that this is C. Since we're trying to find A, B in the center, right, this is useful because this involves C and A. If we have C and A, we can find B as well. Right? Foci. Right, so let's graph this. What does it look like? 0, 8, and 0, negative 8. So 0, 8 is up here. 0, negative 8 is down here. So again, this is going to be going, all right, well, technically it's like this. It's going to be looking like this. So this is opening up and down. So right away, same idea. I know to start off with this. It's called a skeleton. Okay. And the distance. Oh, we found the center. We can find the center. Let's do that. Good. So the middle of 8 and negative 8 is 0, 0. So this is at the origin. Minus 0, minus 0. And the length from the center to the focal point, that's C value. In this case, it's 8. We know C is equal to 8. Right here. Because of that, we can solve and find what A equals. Did you see where I did that? I already had this 4 over 3 equals C over A. And then when I found C, I just kind of wrote right over it. So I can solve this. So I have 24 is equal to 4 times A. So I have a is equal to 6, which means down here is 6 squared for a. And then I'm just missing b, which I have c, which is 8, and I have a, so I can figure out what b equals. Going back to our old trusty friend. So 8 squared equals 6 squared plus b squared, which means b squared is going b is going to be square root 8 squared minus 6 squared. 64 minus 36 is 28. Yeah. That's okay, that's not like a perfect square. That's totally fine. So I'll put b squared, and then just do one more step and simplify all this. So if it's ever minus 0 like this, we don't need to write those. So our final answer could just be y squared over 36 minus x squared over 28. There we go. So again, we'll play a lot with this on Monday and Tuesday, so we got time. I know this is a Friday and everything, and we got a weekend off, but we'll practice this a lot more when we come back and then take your quiz probably on Wednesday at this point.